Right, now we'll start with another chapter of integration. We'll do partial fractions part 2. In part 1 we saw how do we do partial fractions. Here we will see if you have repeated factors in the denominator, then how do you do partial fractions. Let's see this. So we're doing integration partial fractions part 2. We've already done partial fractions part 1. Now we are doing partial fractions part 2. Right? Let's see this. Integral of 2x upon x plus 5 with respect to x plus 5 the whole square with respect to x. Fine? Now, when you have repeated factors, you will say let 2x upon x plus 5 the whole square be equal to a upon x plus 5 plus, look at this guys, this is x plus 5 the whole square. That means x plus 5 has been repeated twice. It's a repeated factor, so b upon x plus 5 the whole square. People, please observe this step very carefully. It's a very important step. So it will be a upon x plus 5 plus b upon x plus 5 the whole square. So this is 2x upon x plus 5 the whole square is equal to, this can be written as x plus 5 the whole square, LCM, a into x plus 5 plus b, common denominator gets cancelled, 2x is equal to ax plus 5a plus b. Equate like terms. If I equate like terms, that means x term should be with x term. Hence, I can say that 2x is equal to ax, in which case I can say a is equal to 2. Similarly, since there is no constant term here, I can say that 5a plus b is equal to 0. In that case, I can say 10 plus b is equal to 0. b is equal to minus 10. Once you've done this, then I can say I is integral of a. A is what? 2 upon x plus 5 plus b minus 10 upon x plus 5 the whole square with respect to x. Right? Split the integral sign. If I split the integral sign, this is 2 integral of 1 upon x plus 5 with respect to x minus 10 upon integral of 1 upon x plus 5 the whole square with respect to x. This is 2 log mod x plus 5 minus 10 integral of x plus 5 raised to minus 2 with respect to x. I am converting the positive indice to negative by taking it in the numerator. This is 2 log mod x plus 5 minus 10. Integral of ax plus b the whole raised to n is 1 upon a, ax plus b the whole raised to n plus 1 upon n plus 1. So this will be x plus 5 raised to minus 2 plus 1 upon minus 2 plus 1 plus c. This is 2 log x plus 5 minus 10 x plus 5 raised to minus 1 upon minus 1 plus c. This can be written as 2 log mod x plus 5 minus into minus plus 10 upon x plus 5 plus c. Right? Let's move on to the next sum, guys. Integral of 3x squared plus 7 upon x minus 1 the whole cube with respect to x. Right? Let's see the sum. This can be written as, you will say let 3x squared plus 7 upon x minus 1 the whole cube be equal to a upon x minus 1. You have to start from indice 1 to the given indice. plus b upon x minus 1 the whole square plus c upon x minus 1 the whole cube. Guys, observe this step very carefully. You have to start with indice 1 till the given indice. Base as it is from indice 1 to the given indice. So, raised to 1, raised to 2, raised to 3. Now, this can be written as 3x square plus 7 LCM a x minus 1 the whole square plus b x minus 1 plus c. Common denominator x minus 1 the whole cube cancel. 3x square plus 7 is a expand x square minus 2x plus 1 plus bx minus b plus c. This is 3x square plus 7 is equal to ax square minus 2ax plus a plus bx minus b plus c. Circle opening the bracket. 3x square plus 7 is equal to, get like terms together, ax square plus x minus 2a plus b plus a minus b plus c. All like terms are together. Equate like terms. If I equate like terms, I will get therefore 3x square is equal to ax square. Therefore, a is equal to 3. There is no x term here. Therefore, I can say minus 2a plus b is 0. We just found out the value of a to be 3. So, minus 2 into 3 plus b is 0. Minus 6 plus b is 0. b is equal to 6. Next, I can say a minus b plus c is equal to 7. A is 3, b is 6, plus c is 7, minus 3 plus c is 7, c is equal to 10. Once you have this, now you can start the sum. I can say I is integral of a we found out as 3 upon x minus 1 plus b 6 upon x minus 1 the whole square plus c 10 upon x minus 1 the whole cube. With respect to x. This is 3 integral of 1 upon x minus 1 with respect to x plus 6 integral of x minus 1 the whole square with respect to x plus 10 integral of x minus 1 the whole cube with respect to x. This can be written as 3 log mod x minus 1 plus 6 integral of x minus 1 raised to minus 2. From denominator to numerator, the sign of indice changes. Integral of x minus 1 minus 3 with respect to x. This is 3 log mod x minus 1 plus 6 x minus 1 minus 2 plus 1 minus 2 plus 1 x raised to n formula plus 10 x minus 1 minus 3 plus 1 minus 3 plus 1 plus c. This is 3 log x minus 1 plus 6 x minus 1 raised to minus 1 upon minus 1 plus 10 x minus 1 raised to minus 2 upon minus 2 plus c. This can be written as 3 log mod x minus 1 minus 6 upon x minus 1 minus 5 10 and 2 gets cancelled upon x minus 1 the whole square plus c. Right? Next, let's see the next one, guys. Integral of x square plus x upon x minus 1 the whole square into x plus 2 with respect to x. Now here you have two factors out of which one is repeated, one is not repeated. Let's see how do we do this. You will say let x square plus x minus 1 the whole square into x plus 2 be equal to a upon x minus 1 plus b upon x minus 1 the whole square plus c upon x plus 2. Now this can be written as x square plus x LCM. This is going to be a x minus 1 x plus 2 plus b x plus 2 plus c x minus 1 the whole square. Common denominator gets cancelled. X square plus x, a, expand, x square plus 2x minus x minus 2 plus bx plus 2b plus c, x square minus 2x plus 1, x square plus x, ax square plus 2x minus x is plus x into a is going to give you ax minus 2a plus bx plus 2b plus cx square minus 2cx plus c. Get like terms together. X square plus x is equal to a plus c x square. I'm getting the x square terms together, plus a plus b minus 2cx, a plus b minus 2cx plus minus 2a plus 2b plus c. So I got all the like terms together. Now equate like terms. If I equate like terms, I will get a plus c is equal to 1, a plus b minus 2c is equal to 1, and minus 2a plus 2b plus c is equal to 0. Square term with the square term, x term with the x term, constant with the constant. Okay. Now let's see this. Let's call this as equation 1, 2 and 3. From equation 1, I can say a is equal to 1 minus c. Substitute in equation 2. If I substitute in equation 2, instead of a, I will write 1 minus c plus b minus 2c is 1. So 1 and 1 gets cancelled. So you will get b minus 3c is 0. Minus c minus 2c minus 3c. So b is equal to 3c. Substitute in equation 1. Substitute in equation 3. If I substitute in equation 3, minus 2a, a we found out as 1 minus c, plus 2b, b we found out as 3c, plus c is 0. So you will get minus 2 plus 2c plus 6c plus c is 0. So 6, 8, 9c is equal to 2. Therefore, you will get c is equal to 2 upon 9. Once I get c, I can find out b. b is nothing but 3 into c, so 3 into 2 upon 9. So that's 2 upon 3. Once I know b and c, I can also find out a. A we had said is nothing but 1 minus c. So this is 1 minus 2 upon 9, 9 minus 2, 7 upon 9. So now I know the value of a, b and c. I'll continue the sum up. We'll continue the sum here. So I can say I is integral of a. A we found out as 7 upon 9 upon x minus 1 plus b. B we found out as 2 upon 3 x minus 1 the whole square plus c, which we found out as 2 upon 9 upon x plus 2 dx. Split the integrals, get the constants out. This is 7 upon 9 integral of 1 upon x minus 1 with respect to x, 2 upon 3 integral of x minus 1 the whole square with respect to x, plus 2 upon 9 integral of x plus 2 with respect to x. This can be written as 7 upon 9 log mod x minus 1 plus 2 upon 3. Take the term in the numerator. So sign of the indice will become negative. Once the sign becomes negative, you can use the formula x raised to n. So this is going to be x minus 1 raised to minus 2 plus 1 upon minus 2 plus 1 plus 2 upon 9 log mod x plus 2 plus c. This can be written as 7 upon 9 log mod x minus 1, 2 upon 3, and this is minus 1. So this becomes minus 2 upon 3 x minus 1. It was x minus 1 raised to minus 1. Convert the negative indice to positive. Plus 2 upon 9 log mod x plus 2 is plus c. That is the answer. Right? Let's move on to the next sum, guys. Last sum to finish this chapter. Integral of x upon x minus 1 upon x square plus 1 with respect to x. Extremely nice sum. You have x square plus 1 where the whole factor is not repeated, but only a certain term of a factor is repeated. Generally we used to have x minus 1 the whole square, that means the whole factor was repeated. Here you have only x square, that means only x is repeated. In which case you will say let x upon x minus 1 upon x square plus 1 the whole square, x square plus 1 be equal to a upon x minus 1 plus, since a factor is repeated, you will write this as bx plus c upon x square plus 1. Factor is repeated, only one term x is repeated. How do you write it in terms of constant in the numerator? You will write it as bx plus c. Guys, please note this step, very important step. Now let's continue ahead. This is x LCM a x square plus 1 plus bx plus c into x minus 1 x ax square plus a plus expansion bx square minus b plus cx minus c. Get like terms together. X is equal to a plus b x square plus cx plus a minus b minus c. A minus b minus c. So I got the like terms together. Equate like terms. If I equate like terms, I will get a plus b is equal to 0 because there is no square term. C is equal to 1 and a minus b minus c is equal to 0 because there is no constant term here. Substitute c here. So I will get a minus b minus 1 is 0. Therefore a minus b is equal to 1. Equation 1, equation 2, equation 3. Solve 1 and 3 simultaneously. So I'll get 2a is equal to 1 plus b minus b gets cancelled. A is 1 upon 2. Once you get the value of a, you can find out the value of b and c. I can say a plus b is 0 from equation 1. So I will say b is equal to minus 1 upon 2 because a was 1 upon 2. Once this is done, now you can solve the sum. I can say I is integral of a was 1 upon 2 x minus 1 plus b is minus 1 upon 2 x plus c we found out as 1 upon x square plus 1 dx. Fine. This can be written as 1 upon 2 integral of 1 upon x minus 1 with respect to x plus integral of, this is going to be minus x plus 2 upon twice x square plus 1 dx. Guys, what did I do? I took LCM. Minus x plus 2 and that common denominator 2 I brought down. Split the numerator. So this is 1 upon 2 integral of 1 upon x minus 1 with respect to x plus 1 upon 2 constant outside. Split the numerator. Integral of minus x upon x square plus 1 with respect to x plus integral of twice integral of 1 upon x square plus 1 with respect to x. Right? This can be written as 1 upon 2 log mod x minus 1 plus 1 upon 2. Now, the degree of polynomial in the numerator is less than that in the denominator. I can make the numerator to be the derivative of denominator. How? What is d by dx of x square plus 1? D by dx of x square plus 1 is 2x. So, to get a 2x in the numerator, I can multiply by 2 and divide by 2. Get the minus sign outside. Divide by 2 and multiply by 2. I have divided by 2, multiplied by 2 upon x square plus 1. Thus, the term in the numerator now is the derivative of the term in the denominator plus twice integral of 1 upon x square plus 1 square with respect to x. Now, this can be written as 1 upon 2 log mod x minus 1 plus 1 upon 2, 1 upon 2. This is going to be f bar of x upon f of x. Integral of f bar of x upon f of x is log mod f of x. Log mod x square plus 1 plus twice. Integral of 1 upon x square plus a square is 1 upon a tan inverse of x by a. So this will be straight away tan inverse of x plus c. That is going to be 1. Right? If you want, you can further simplify by opening this bracket. This will become 1 upon 4 and the 2 and 2 will get cancelled. I'll just show that to you. Let's move on and let's just write that final answer. This is going to be 1 upon 2 log mod x minus 1 plus opening the bracket will give you 1 upon 4 log mod x square plus 1. 2 and 2 gets cancelled plus tan inverse of x plus c. That will be your final answer. This finishes this chapter, partial fractions part 2. Thank you very much.